Okay, so today we're going to talk about compounds and mixtures and how they are different from elements. So most elements that we see on the periodic table are not found in their pure form. That means they're going to have more than one element, and most likely they're going to be found as a compound. For example, NaCl is sodium and chlorine, which makes up salt. So a compound is formed when you have two or more different elements that are joined together chemically. It's not easy to separate elements in a compound, but it can be done. So if we think about when elements combine, they're going to act differently than when they're alone. For example, hydrogen and oxygen on the periodic table are a gas. They are both gases. But when you combine two hydrogen and one oxygen, it turns into H2O, which is a liquid at room temperature. So compounds are going to be represented by a word that we call a chemical formula, which shows how many atoms of each type of element make up that compound. Okay, for example, CO2 has 2 parts oxygen and 1 part carbon. So it's kind of like your recipe. It's going to tell you how much you have of which elements on the periodic table. So for example, if you have 1 molecule of carbon dioxide, the formula is CO2. So it's going to have 1 part carbon and 2 part oxygen, and they're combined together. They're joined chemically and bonded. We'll talk more about bonding later. That number that you see that is kind of lower and smaller than those letters is what we call a subscript. So think the stem sub means under. And a subscript is going to show you the number of those atoms of each element. Okay? If it does not have a subscript, then it's kind of like there's an invisible number 1. Because if it was 0, then the letter wouldn't be there. If it was 2, we would have the number 2. So if we look at a molecule of water, okay, so we have the subscript of 2 here. This belongs to the letter before it. So there are 2 parts hydrogen and 1 part oxygen. So the oxygen, has no subscript, so we know that there's only 1 part oxygen in that compound. Another example, NaCl, there's 1 part sodium and 1 part chlorine, so neither one of them has a subscript, so there's just 1 part of each in that compound. 1 molecule of sugar is the formula C12H22O11. So if we think about those different parts, we're going to break that down into what we call a brace map, and it's kind of like our recipe. So we're going to see how much we have of each, okay? So if we have C12, if we write out how much we have, it's C12. So we have C 12 times. We're going to go to a next row. We have 22 H's. Next row, we have 11 oxygen. So that's how we're going to set up our brace maps, and that's going to show us how many parts of each element we have in that compound for that chemical formula. Okay, switching to mixtures. So a mixture is also a combination of 2 or more substances or elements that are blended together without a chemical reaction. So what happens is each of those substances are still kind of acting the same as they did before they're being mixed. Mixtures can be easily separated again. So let's look at some examples. How can those mixtures be separated? If we have metal that are in a liquid, we can use a magnet to separate them. If you have something like salad, you could use your hands to just kind of sort. If you don't like tomatoes, you can just pick them out. That would be a way you could separate that mixture. Sometimes we can pass a substance through a filter paper, for example, a coffee filter. Sometimes if you have a mixture that is like sugar water, you could let the water evaporate if you leave it sitting out for a long time, and then that solid would be left behind. So what about some other examples of mixtures? Orange juice with pulp in it would be an example of a mixture. Salt water, again, if we use that example, that would be an example of a homogeneous mixture because it's kind of the same throughout. If you had just sort of a plain chocolate milkshake, that would be a homogeneous mixture as well. Chex Mix down here would be more of a heterogeneous mixture. You can kind of see the different parts throughout there. Kool-Aid, also homogeneous. Soil right here would be heterogeneous. You can kind of see some of the different parts in there if you have rocks or twigs or maybe some earthworms in there. And chocolate milk would also be a homogeneous mixture. So let's hop back to what is the difference between homogeneous and heterogeneous, okay? Now these terms only apply to mixtures, not compounds. Homogeneous, they're going to consist of parts of all the same kind. So it's going to kind of look the same consistency throughout, like Kool-Aid. Heterogeneous, on the other hand, is going to be kind of consisting of different parts that you'll be able to see, like salad. You can see the different parts that you put on that salad or that mixture, okay? So just to review real quick, compounds have a chemical formula. Water is a compound. The formula is H2O. They are not easily separated, okay? Mixtures, on the other hand, can be easily separated. We talked about a variety of ways that they can be separated. They don't have a chemical formula, and then they're either going to be homogeneous or heterogeneous. And that's what you need about compounds and mixtures.